Hi, everyone. Today's lesson is on trigonometry applications regarding the unit circle. So let's get started. First thing we're going to do is a little warm up, and that is with these two special right triangles. Things that you want to remember, that if you do have a right triangle and it is a special right triangle, meaning let's say it's a 45, 45, 90. So that's your 45, 45, 90. What you should remember is that that's x, and that's x root 2. So basically that means is if this is a unit circle and we have a 45, 45, 90, again, you know it's 45 because the two sides are congruent and isosceles. And if it's a unit circle, this would be 1, radius would be 1 square root of 2. And so that's what we're thinking when we're thinking about a special right triangle that's a 45, 45, 90. When you're thinking about a right triangle that is a special right triangle that's a 30, 60, 90, what you're going to see is across from the 60 is going to be root 3. Across from the 30-degree angle is your 1 regarding your unit circle. Across from the 90 is 2. That stems from this being A, this being 2a, and this being a root 3. So if a is 1, you have 1 root 3, and you have 1 times 2, which is 2. So keep that in mind. This works pretty well, except when you're going backwards. So what I mean by that is if I have a 45, 45, 90, okay, and I know this side is, let's say, 5, not on the unit circle. So 5, let's say that's 5. This is going to be 5 root 2, and this is if it's a 45, 45, 90. But what if this wasn't all nice and neat in 5 root 2? What if it was, they gave you this is 10, and they asked you to find x, or this x, which we know are the same because it's 45, 45, 90. Well, there's a couple of options for that. You can do this, and you can go x squared plus x squared is equal to 10 squared, which is Pythagorean theorem. 2x squared equals 100, x squared equals 50, and then you have x equals the square root of 50, which is root 25 times root 2, so 5 root 2. So x would actually equal 5 root 2. Now, there is a shortcut to that, and that shortcut is to take the value that you have, which is 10, divided by 2, multiplied by root 2. So now you have 5 root 2. So this right here is our little trick, okay? You definitely can do it this way. This is a little bit shorter. Likewise, if you have a 30, 60, 90 right triangle, and let's say across from the 60 is not something super neat like root 3 or 2 or 1, something like that. And for example, across from the 30, let's say is 5. Across from the 60, well, then would be 5 root 3. And across from the 90 would be 2 times 5, which is 10. What if, though, instead of them giving me a really nice number, I got, instead of 5 root 3, let's say I got 15. Well, you would work backwards, and so basically the rule would be to take 15, you would divide by root 3, and then, well, actually, you multiply by, let me do that again. You would divide by 3, and then you would multiply by root 3, okay? And so that's what you would be doing. You'd start off by dividing by root 3, because if this value right here, this 5 root 3 was, let's say, 15, you could set that equal to a root 3, and then you would divide by root 3 and then simplify. Anyway, going back to the problem says you have x, across from the 30 is x, across from the 60, this is your 12. We're going to set that equal to a root 3. We have a equals 12 divided by root 3. So we're going to simplify that by multiplying by root 3 over root 3. So I get 12 root 3. So I get 12, I know this is a little bit small, 12 root 3 over 3, which I can even simplify further into 4 root 3. So across from the 30 is 4 root 3. And then across from the 90 is twice that, so that's going to be 8 root 3. And going back to the left side of the triangle, which is a 45, 45, 90, if that's 4 root 3, that's 4 root 3. And this would be 4 root 3 root 2. Remember, this is x root 2. And if this is x, I just have to multiply those two out. So my z is going to be 4 root 6. So z is 4 root 6, y was 8 root 3, and I believe x was 4 root 3. All right, so a little bit of review in that and all that. To find all the sides of the triangle, obviously we have all the angles. Remember, this angle here and this angle here have to add up to be 90 degrees. To find the other sides, I'm just going to label this. I'm going to call this A, I'm going to call that B, and I'm going to call that C angles. Keep in mind that when you're talking about angles, you always use the capital letters, okay? So that means that this side would be little a, this side would be little c, and this side here would be little b, which we already know is 7. We're going to use SOHCAHTOA, which is sine, cosine, and tangent. So this is a little mnemonic. A mnemonic is something that you use to help you remember how to do something. For example, I remember the one I had from history years and years ago. We had Holmes. And what Holmes was Huron, Ontario, Michigan, Erie, and Superior. And what these were these are the Great Lakes. But anyway, this is a mnemonic. A mnemonic is basically something to help you remember something. So this is what we call SOHCAHTOA. And what the mnemonic stands for is meaning that sine of an angle is equal to the opposite side over the hypotenuse. Cosine of an angle is equal to the adjacent side over the hypotenuse. And tangent of an angle is equal to the opposite side over the adjacent side. So we're going to use one of these to solve this triangle. And when I mean solve the triangle, that just means that you're supposed to find all the sides and all the angles, but we already have the angles, so we're good. Another just real quick before I move on, this angle right here, see how I said sine of an angle, cosine of an angle, and tangent of angle? Keep in mind, you're always saying the whole word. So I'm saying sine, I'm saying cosine, and I'm saying tangent. I'm saying the entire word. Even though I'm abbreviating as I'm writing, I'm still saying the entire word. You're never going to say sin, theta, cos. You're never going to say that. You're going to say the entire word anyways. Remember to always put the angle right after that. Okay, so I'm going to find little a. I'm here at angle A. So to find little a, this is opposite from where I'm at, this angle. Okay, so I'm going to use opposite and adjacent. So opposite and adjacent is tangent. So I'm going to go tangent of 37 degrees is equal to opposite over adjacent, tangent. Okay, now if I have a calculator, I can definitely solve this, but without a calculator, all I can do is multiply. If I have one term on the left and one term on the right, I would cross multiply, and I'm going to get a times 1 is a, is equal to 7 times tangent of 37 degrees. So that's actually how I would leave my my answer on a test if I'm not allowed to use a calculator. I do have a calculator in front of me, so I am going to try to give you this answer and so that you can check your work. So that's tangent of 37, and then I'm going to say times 7. And I'm going to go enter, and that's about 5.27. So I'm going to go about 5.3. So A is about 5.3. All right, so I would put that here, 5.3, about. So you usually use the squiggly lines like that. It's an approximation. To find little c, okay, in order to find c, that's my hypotenuse. So in a hypotenuse, remember, is the side opposite the right angle. So to use the hypotenuse, I'm basically going to use either sine or cosine. So I would say, I'm just going to use sine. So I'm going to stay here. I'm just going to keep using angle A. So I'm going to go sine of angle A is equal to the opposite side, which we know is 5.3 divided by C, which we're trying to find. Now, remember, you can only have one unknown in a problem, but actually, see this A, I already know what that is. That's 37. So we have sine of 37 degrees is equal to 5.3 is equal to 5.3 divided by C. For this problem, I'm actually going to cross multiply and then divide. So I'm going to go C times sine of 37 is equal to 5.3. So C is equal to 5.3 divided by whatever sine of 37 is. And that's a quantity. Keep that in keep that in parentheses. So if I were doing this, I'd go 5.3 divided by, say, parenthesis, whatever sine is of 37. And I'm going to go enter. I've got 8.8. So C is approximately 8.8. And the reason why I went through with this, 8.8, and that's this value here. One thing that you should verify, and that is that your hypotenuse, the 90 degrees, is your largest side or your largest angle in this triangle. And your largest angle needs to be opposite the longest side. So if you look at this to verify, you'll see that 90 degrees is in fact opposite 8.8, which is the largest side. And the smallest side, which is the smallest angle, which is 37, is opposite the smallest side, which is 5.3. So another thing that you could do to verify. So this is given sine of 20 degrees is equal to this value here, all right? And you're given cosine of 20 is equal to 0.94, and you're given that tangent of 20 is equal to 0.364. And your job is to find the 6 trig function values of 70. Now, we did this in class. What we learned in class was that these were what co-functions are. And this was actually on my last video. So when you get to see this kind of thing, if you want to review, you can look at the video prior to this, which dealt with co-functions. This would be a problem that you would solve, and you would not be able to use calculators. Okay, and what your job is to do is you're basically trying to manipulate these numbers. You're trying to find sine of 70 degrees. You're trying to find cosine of 70, tangent of 70, cotangent of 70, secant of 70, and cosecant of 70. Now, we're using our reciprocal functions for this too. So you're definitely not allowed to use calculators. So without calculators, how would you do this? I always suggest to my students that you should write down what you know, okay? What you know regarding cofunctions is this, that sine of 20 degrees is equal to cosine of 70. And what this means is that these two angles here, these have to add up to be 90 degrees, okay? These are called cofunctions, and they do need to be complementary. So those are equal. You also know that cosine of 20 is going to equal to sine of 70. You know that tangent of 20 is going to equal cotangent of 70. So I always tell people to write down what you know. You know this based on our cofunctions, okay, where these two angles are complementary. You know this. And if you know that, okay, you can answer all these problems because you know that sine of 70, well, that equals cosine of 20. I have cosine of 20, it's up here. And so cosine of 20, which is sine of 70, is 0.94. Now, cosine of 70, that's right here. Well, what does that equal? That equals sine of 20. So that's going to be sine of 20. That's going to be sine of 20 degrees. And we actually know what sine of 20 is, and that's going to be 0.342. Now, tangent of 70, I don't have that one, but I do have cotangent of 70, which is tangent of 20, which is 0.364. So if nothing else, you already know these things. Now, what happens here is this. Tangent of 70 is actually, tangent of 70 is the same thing as saying, tangent of 70 is going to be cotangent of 20, but it's the same thing as saying 1 over cotangent of 70, because what these are reciprocal functions. So actually, I can take cotangent of 70, which is this, and make that, flip that upside down. So that's going to be 1 over 0.364. Now, without a calculator, if you're not allowed to use calculators, you can just leave it like that. Now, remember secant is reciprocal of cosine, SC, cosine. And so that could also be written as 1 over 0.342. And lastly, cosecant is the reciprocal of sine. And so that can be rewritten as 0.94, 1 divided by 0.94. And so those are your answers. Those are your cofunctions. Something to remember, and I know we talked about this in the last video, but another way of writing tangent, okay, tangent of an angle is sine of that angle divided by cosine of that angle. Well, if I'm looking at tangent of 70, then that's the same thing as saying sine of 70, that one, divided by cosine of 70. So I also could write this over this. And that would also be accurate because that's what tangent is, opposite over adjacent, or sine over cosine. All right. Likewise, with cotangent, I could do the same thing. I could have said cosine over sine. So I could have rewritten this as 342 divided by 0.94. And that would be correct. That would give me an accurate number. Okay, moving on. So basically what this is just telling me what to solve. Just a little bit of vocabulary. Solve means triangles. To solve a triangle means to find all the sides and all the angles. Something to look at is, here's A. These are all capital letters, and these are little letters. All right, so not capital. We use those to represent sides, and angles, we use the capital letter. In addition to this, here's one that says solve the following right triangle. So if I'm solving this right triangle, what I'm looking at here is to find all the sides and all the angles. So I could just find the angle here. So I would go, well, what's 90 degrees minus 61.7 degrees? So borrow, what is that? Okay, so you're just borrowing. So that's 28.3 degrees. That's right here, 28.3. Okay, not awful. That's pretty easy. Okay, in order to find A and B, you have so many choices. For A, I'm going to use A. I'm going to put myself, a lot of people, like I said before, put themselves here at the angle that they're at. So like if you're using this angle A, they like say, okay, here I am here. Or if I'm using angle B, they're like, okay, they draw the person up here. So to find little a, I cannot use tangent because that would be opposite over adjacent. And I don't have enough information to do that. So I do need to use either sine or cosine. I'm going to use sine if I'm here at angle A. So I'm going to go sine of 61.7 degrees is equal to opposite over hypotenuse, 106.2. So to find little a, if I am not allowed a calculator on my assessment, I would go, well, that's 106.2 times sine of 61.7, and that's my answer. That's how I would leave it. If I am allowed a calculator, then I would go 106.2 times parenthesis, put my trig function in. This is going to be sine of 61.7 equals, and I've got 93.5. I would also suggest, what is that, 93.5. I would also suggest that you check your calculator and make sure that you are in degree mode. Because if you're not getting the same answer as mine, that means that instead of using degrees here, you're using radians, which is going to give you an answer, but not in degrees. So it wouldn't be accurate. So little a is about 93.5. Okay, we're happy with that. That's A. A is done. To find B, I have lots of choices, okay? I'm just going to write down some of my choices that I have. Pick one. Whichever one works for you, that's the one you should use. What speaks to you. A lot of people go, oh, I have two sides of a right triangle. I'm going to use Pythagorean theorem. So I could go A squared. Can we use the right number? I'm going to use A squared. So I'd go 93.5 squared plus B squared is equal to 106.2 squared. That's one way I can solve for B. And so, again, if I'm not allowed a calculator, this is what I would do. I'd go 106.2 squared minus 93.5 squared, and then I would square root that, because without a calculator, this is what you can do. 106.2 squared minus 93.5 squared. And no, you don't square those and subtract. You leave it just like that. Another option I could do, as long as I'm down here at A, to find B, I could say, well, tangent of 61.7 is opposite over adjacent. And so I could cross multiply. And so let's see here, B times tangent of 61.7 is equal to 93.5. So B is equal to 93.5 divided by tangent of 61.7. Okay, so this would actually be my answer if I'm not allowed a calculator. Another option for finding little b might be to use tangent from this angle right here. I could do that. I could say tangent of 28 point, what is that angle? 3 is equal to opposite over adjacent, which is 93.5. Solve for b. Another option, go back here, and I'm going to use cosine. I could say cosine of 61.7 is equal to adjacent over hypotenuse and cross multiply. So you have a lot of options for this to find little b. Keep in mind that both A and B have to be smaller than 106.2, because the longest side has to be opposite the largest angle. And since 90 degrees is my largest angle, this has to be the largest side. So that means both A and B, whatever those are, have to be smaller than 106.2. So this one says solve the following right triangle. Now this one, this has two parts. The first part's pretty simple, find A. So we're going to go 13 squared plus A squared is equal to 23 squared. So what is this? 169 plus A squared equals 23 times 23. What is that? 529. Oh, I know that. So here's 529. To get A squared, you're going to go 529 minus 169. So A is equal to the square root of, let's see here, minus 169. I get 360. So if I square root that number, I'm going to get 6 root 10. Yeah, well, this is 360 here. But what that becomes is 6 root 10. And I don't know if you need a little brush up on how to solve for roots or not, but basically you're just going, that's 36 times 10. And root 36 is 6, so that's just 6 root 10. So that's pretty simple. So this one is equal to 6 root 10. All right, so now we found all the sides, so that's good. What we need to do now is to find little a, or angle A and angle B. Pick one. I'm just going to choose A. So I'm choosing A. Put yourself at the angle. We're going to call this theta, okay? Theta. So in order to find theta, and when I say theta, I'm saying this, theta, like that. That just means angle. Theta means angle in Greek. But anyway, so in order to find that, I'm going to use either, I have all the sides. So if you have all the sides, you can use sine, cosine, or tangent. You have options. I'm going to use cosine. So cosine of theta, here you are, cosine is adjacent over hypotenuse. So cosine of theta is equal to 13 over 23. Now your job is to isolate theta. So here's the thing with this. Let's say I have x plus 7 equals 10, right? You're going to get the 7 over to the other side to isolate the x, right? In order to get the 7 to the other side, you're going to do its inverse. So what's the inverse of plus 7? Negative 7. So you're going to do its inverse. So if I had a 2 in front of my x, what's the inverse of getting rid of, how do I get rid of the 2? You would divide. That's your inverse. So what you're doing is you're going to be finding the inverse to get theta by itself. You need to move this cosine over to the other side. The act of doing that, moving it over to the other side, the inverse, is what we call arc cosine. Now, I am saying this, arc cosine. That's what I'm saying. I'm saying that. But I'm writing this, okay? So when I say arc cosine, this is what I write. So says theta equals arc cosine, that's my inverse, of this value, which is 13 over 23. So theta is about, let's see here, go to your calculator. Let's see, arc cosine, that's going to be 13 divided by 23. I get 55.6. So this is about 55.6 degrees. And if I go 90 minus 55.6 degrees, this value here, up here for little b, is going to be what, 34.4 degrees. Okay? All right. Couple things for when we are talking about applications of trigonometry. We have two things called the angle of elevation, and we have the angle of depression. Now, most of the time, the kind of problems that you're going to see is like, here you are on a cliff, let's say, looking down at the boat, which is way down here, okay? And you're looking down. When you're looking down at an angle of depression. Angle of depressions are always on a horizontal. This is my horizontal, right? Horizontals are based on a straight line going across. But the thing is let's say they say, you're looking down at the boat at, I don't know, 35 degrees. Well, that angle here is 35 degrees. They say you are up on the cliff at 300 meters. Okay, well, there you are. And how far from the boat are you? Okay, so you want to find that. Or how far from the boat is from the base of the cliff? Well, this 35 is actually not in my triangle. So what you need to remember is this being on the horizontal is also like this, right? This line here starts to act as my transversal. And if this is 35, and you know horizontals are all parallel, of course, that makes this 35 degrees too. So when you're doing something like this and you wanted to find this, you would then say, well, tangent of 35 is equal to opposite, which is 300, over adjacent, solve for x. Now you know how far the boat is away from the bottom of the cliff. Likewise, when you are standing here and they say, okay, here you are looking up at the sun, okay? So let's say you're here looking up at the sun. When you look up, this is how you're looking up, okay? So you're looking up like this. So we're going up. And so this angle right here, which may be, let's say you're looking up at a 20-degree angle, look what happens, okay? If I extend this and bring this down like this, see this? That's my look up. That's my angle of elevation. This is my angle of depression. You see what I'm saying here? These are alternate interior angles. So my angle, long story short, angle of depression is the angle of elevation. Okay, they're the same value. This is just another way of saying that. A couple of the application problems will be asking you for the line of sight. That's your line of sight like that. Angle of elevation, again, that's going up. Keep in mind, if I wanted to, I could put my straight horizontal line like that. I could be standing up here, and there's my angle of depression. See that? Angle of depression happens to be the same thing as the angle of elevation. Pretty interesting. Okay, so first things first, you're just trying to solve for this. This says D for distance or depth. Yeah, let's go with depth. This is the angle right here. And so you're trying to find D, the depth. You're down here, let's put us by the anchor, where we really shouldn't be, but that's where we're at. So the anchor is down here, that's opposite, and this right here is my hypotenuse. So which one uses opposite and hypotenuse? Okay, that would be sine. So remember, so ka toa. So we're going to go sine of 39 degrees is equal to the opposite side, which is D, over the hypotenuse, which is 30. And so D is going to equal 30 times sine of 39 degrees. So I don't know what that is. Let's see here. We're going to go trig functions, sine of 39 degrees. Okay, get that number. And we're going to say times 30. And I get 18.87. So my depth is now about, because I rounded off, 18.9. And I'm going to say, I'm sure that that's meters or something bigger. Okay, so that's what we have. Yeah. So solve this one. This one is actually a trick question. They're just asking you to find n. N is this angle in here. So simply for this one, you're going 90 minus, you're going 90 minus 16 degrees. So what is that? 9, 8. That's a 4, 74 degrees. So the measure of angle n is equal to 74 degrees. Okay. This one here, though, we're going to try to find the height for that. So notice that I don't have a hypotenuse here. Well, if you remember your sign, so, ka, toa. The only one that doesn't use my hypotenuse is tangent. See, there's my h, hypotenuse, hypotenuse. So there's my hypotenuse here. I don't have that. I'm not trying to find it. So I don't need to use sine or cosine. So I would say tangent of 55 degrees is equal to opposite. So x over adjacent, which is 57. And so x would equal 57, because you're going to cross multiply, times tangent of 55 degrees. And so without a calculator, that's my answer. With a calculator, I'm going to go 57 times tangent of 55, and I get 81.4. So that means that 81.4 is my height of the building. Okay? All right. The next problem, this is kind of a neat problem. This is just based on Eiffel Towers. Find the height of the Eiffel Tower. So we're looking for that x. A lot of the problems that you're going to see are going to come down. Notice this is my height, because your height's always going to be perpendicular, where you can assure a right angle here. So what you basically have is this triangle right here. You're trying to find x. You know that's a right angle. Half of this is 80, and this angle of elevation, which is 85.361 degrees. And what they're looking for is to find the height. Well, I don't have the hypotenuse. So if I don't have the hypotenuse, I can't use sine or cosine. So I'm just going to use tangent. So we're going to go tangent of the angle. Remember, the angle always goes after the word tangent, sine, cosine. So we have tangent is equal to x over 80. So x is equal to 80 times tangent of 85.361. So now if that's my answer without a calculator. So with a calculator, this is about, so I'm going to work that out. So 80 times tangent of 85.361, and I get 985.9. So 985.9. And so there you go. There's my height. I'm guessing that it's feet, because that the other part has feet. So this is feet. Okay. So this problem actually is pretty tricky. If you pause for a minute, try to set this up. If you pause the video for a minute and you try to set this up yourself, read the problem, set it up. Okay. All right. So without that, what this question is actually asking you to do, and I know I made this kind of small, but what this question is actually asking you to do is to find the height of the statue. I don't think you can see that. To find the height, there we go. To find the height of the statue that's standing on top of this building. Okay, so basically what you're doing is you have two separate triangles. You've got one triangle that goes to the top. Okay, I'm not sure if that comes through as I'm not pretty clear. Anyway, so we have one triangle that goes to the very top of this goes to the top of the triangle, or top of the statue. And then you've got another triangle that doesn't go to the top. It goes partway down, okay? Either way, you know, these are both 400 feet because that's how far you are away. That's how far the distance is from the middle of the building. So meaning you're going to draw this straight down the middle like we were talking about in the last problem. You draw it straight down the middle, so that's going to give you your altitude. So this is 400. It says that the two angles that they're looking up are 56.5 and 55.1. What you need to remember is that as you're looking up, if you look up, it's like you get closer to something and you're looking up, you're actually, your neck's going back farther. You're looking at a higher degree. So the top, at the very, very top, that's going to be a higher degree. So that's going to be 56.5 degrees. This one is going to be 55.1 degrees, okay? And like I said, what we're looking for is, I'm going to call that X and that Y. What we're looking for is the height of the statue, not the height of the building, but the actual height of the statue. So I'm going to go, I don't have any hypotenuses, so we're going to use tangent. So you're basically going to go tangent of 56.5 is equal to X over 400. And the other equation is going to be tangent of 55.1 is equal to Y over 400. And so tangent, so let's see here, trig. So I'm going to go tangent of 56.5 times 400. And that's not the answer. Okay, let me try this again. So I'm going to go trig, tangent of 56.5, and then I'm going to take that number and times it by 400, and I get 604.33. So the highest value, the top, is 604.33. So that's X is equal to 604.33. And the bottom is, I had to work that out. So that's going to be, let's see here, tangent of 55.1, get that number, multiply by 400, and I get 573.39. So Y is equal to 573.39. And so basically to find this distance in here, you're just going to go X minus Y, tall minus small. So you're just going 604.33 minus 573.39, and you get 30.94. So the height of the statue, so like therefore, that means therefore, the height of the statue is 30.94 feet. Okay, and that's it. This is just another way of, all this slide does is it splits everything up so that you can see what I did on the previous screen. So here's a new one. This one says, in order to get the best photo of San Francisco as the sun sets, it's best to be high above ground in a hot air balloon. So here's our balloon. Oops. Okay. So here's our balloon. And let's see, here's our hot air balloon thing. What we do know is the balloon is 352 feet off the ground. So there's 352. Oh, we have a line of sight. So remember, line of sight, that's that line. And the distance to the base of the line of the base of the balloon is this value. So let's see here. The line of sight distance is 627. Okay. What is the current angle of depression? Well, remember, my angle of depression is based on my horizontal. So I'm looking for this angle right here because that is the angle of depression. But with that in mind, if these are parallel, that makes this the same angle as this. And so now my little angle is inside my triangle. Okay, so what I'm going to do is put myself here, okay, at the angle that I'm trying to find. And whenever you're trying to find an angle, make a note to yourself when trying to find an angle, you're going to use arc. You're either going to use arc cosine, arc tangent, or arc sine. In this case, I'm going to use arc sine. So I'm going to show you how I do that. So we're going to go opposite over hypotenuse. This is the opposite side. This is the hypotenuse. So we're going to go sine of theta is equal to 352 divided by 627. And remember, I'm trying to find the angle, that angle of elevation. So we're going to go theta equals arc sine. Remember, this has to go over to the other side. So arc sine of whatever 352 divided by 627 is. So, all right, go to your trig functions. I'm going to go arc sine of 352 divided by 627. I get 34.15. So we're going to say theta is about 34.2 degrees. Okay, so box that up. And that's your, that's the angle of, what is that? That's the angle of depression. Okay, so this was a bunch of around the room problems that we did in class. So I'm going to go through some of these. I'm just going to find one positive and one negative based on time. Find the two positive and two negative angles that are coterminal. Coterminal means ends at the same place. Okay. So what I'm looking for are two angles that end at the same place. So here's my angle. Remember, on an axis, you always start here at 0 degrees. This is going to go up to 51 degrees. So here's 51 degrees. What I need to know is another angle that's going to end at 51 degrees. So the first thing you can do is you could say, well, I want to end in the same place. That's what coterminal means. So basically, in order for me to end in the same place, one option is to go all the way around. That's 360 degrees plus another 51 degrees. So you have 360 degrees plus 51 degrees. And what is that? 411. There you go. 411 degrees. That's a positive angle. Now, if I want a negative angle, I'm going to go the opposite way. And so basically, I'm going to start here and go around this way. And so what I'm doing is I'm going 360 minus 51 degrees, but I'm going in the negative direction. So this value will be negative. And what do you get? 309. So 309 degrees. So that's my negative value. For this one right here, same thing. I'm starting at negative 7 degrees, so that's down this way. So this value is negative 7. I want to get there. So one way I can get there is to go all the way around this way, which is positive. So another way to end in the exact same place is just 360 minus 7 degrees. And so that's a positive angle. So that positive angle would be 353 degrees. A negative angle, that would go the other way. I'd have to basically go all the way around once and then another 7. So you're going 360 plus another 7 is 367. But keep in mind, you are going in a negative direction. So that's a negative 367. Okay. The second problem, I love this problem. This one says, find the 6 trig functions of this. It says theta is in quadrant 3. So here we go in quadrant 3. So this is quadrant 1, this is 2, 3, and this is quadrant 4. Okay. So your job is to find, let's see, I'm in quadrant 3. So 1, 2, 3. So I'm down here. Okay. And remember, all of your angles have to come back up to the x-axis. Every one. You are never going to go to the y-axis. Negative 4/7. Here's theta angle that was a reference angle. So negative 4 opposite over hypotenuse. Okay, this is sine, which is opposite over hypotenuse. To find this third side here, I'm going to use Pythagorean theorem, which basically is, I'm going to use 49 minus 16, and I get 33. So this is the square root of 33. But be careful because this is negative because I am going to the left of the 0 here. Going to the left is negative. So my 6 trig functions, I already have sine, are going to be cosine of theta, tangent of theta, cotangent of theta, secant of theta, and cosecant of theta. Okay, now cosine of theta is adjacent over hypotenuse, so that's going to be negative root 33 over 7. Tangent of theta is opposite over adjacent, so that's going to be 4 over the square root of 33. Remember, you don't leave a root on the denominator ever, so we're going to multiply, and I'm not going to do this every time, but I will show you that I am multiplying by 1 in the form of root 33 over root 3. So I will get 4 root 33 over 33. And that's my answer. Now, cotangent is the reciprocal of tangent. So that's going to be a little nice one. So 33 over 4. Secant is the reciprocal of cosine. So that's going to be negative 7 over root 33. Again, don't leave that down there. So you have negative 7 root 33 over 33. And cosecant being the reciprocal of sine was up here, so that's going to be negative 7/4. Now, couple of things. You're trying to find theta, and you're trying to find your reference angle. Now, keep in mind, we do use this is reference. So this is my reference angle, but we also use this with like a prime. Okay, so in order to find theta, I'm going to use sine, and I'm going to try to find theta. So on a sidebar, you're going to start off with sine of theta equals negative 4/7. Then you're going to go, well, theta is equal to arc sine. Remember, I'm trying to find the angle. So I have to use arc sine, parentheses, negative 4 over 7. So theta is about, and I'm not sure what that is without a calculator, so that's what I'm going to do. Trig function, arc sine of negative 4 divided by 7. And I got 34.8. So I'm going to go with 35 degrees. Well, 34.8. So we get 34.8 degrees. Now, that's my reference angle, 34.8. Because keep in mind, here you are down here is 34.8 degrees. All right. You always start at 0. Okay. You always start on this side. This is called the initial side. All right. So you start here, and your job is to get over here. All right. That's not 34 degrees. That's 34 plus this value, which is 180. So it's like 180 plus 34 degrees. So if I have 180 and I'm adding my 34 degrees, what's that, 214? So my actual angle is 214.8 degrees. That's theta. Theta is my angle. Theta is this. That's theta. Theta is 214.8. Okay. This angle in here, right here, just from here to here, that's my reference angle. Okay. Oh. Okay. We'll accept that later. Okay. All right. Next, find the reference angle and exact function values for sine, cosine, and tangent. So again, 225 degrees. Start at 0, go along past 90, past 180. Here. There we are. Where are we? We're in the third quadrant. Okay. And theta is equal to 225 degrees. Now they're not asking for theta. They want my reference angle. My reference angle is theta prime, or theta reference. They want, how do I get back home? Home is my x-axis. This is where your reference angles will always go back to the x-axis. And what I mean by that is if I draw an angle and I'm in first quadrant, I'm going back to the x-axis. If I draw an angle and I'm in the second quadrant, I go back to the x-axis. If I draw an angle and I'm in the third quadrant, I go back to the x-axis. And if I draw an angle and I'm in the third or fourth quadrant, I'm always going to go back to the x-axis. Your reference angles are all these little angles right in here. That's what they are, those little angles. Okay. Okay. I only wanted to verify. Oh, okay. All right. So what we have is find the reference value. So I need to know what this value is here. So I'm going to go 225 degrees minus 180. Okay. So that's going to be 45 degrees. All right. There's 45. So theta reference is 45 degrees. Now, my next job is to find the values of sine, cosine, and tangent. Be careful. Oh, I'm not allowed a calculator. Well, obviously, okay, because why? Okay, why do I say obviously? Obviously, because it's a 45-degree angle, meaning that's an exact value, and we know those special right triangle. Remember, 1, 1, the square root of 2, x root 2. That's your 1. But because I go this way, that's going to be left. That's going to be negative. Because I go down, that's also going to be negative. So if I want sine of 225 degrees, that's going to be opposite over hypotenuse. And again, don't leave a root on the denominator. So you get negative root 2 over 2. Cosine of 225 is always going to be the same as sine. The negative and positive might be different, but because it's a isosceles triangle, two sides are always going to be the same. And lastly, tangent of 225 is going to be opposite over adjacent. So that's negative 1 over negative 1, which is 1. A couple of the questions that I'm often asked about this problem, and that is this angle right here. Why am I using 225 if this is 45? 45 is only my reference angle. I'm actually finding sine of 225 degrees. If you always use a reference angle, then you're always in the first quadrant because all your reference angles, remember, are less than 90 degrees. They're greater than 0. Reference angles are greater than 0, but less than 90. So if all I found for all of the problems that I have are my reference angles, then every single answer is going to be positive because I'll always be in the first quadrant. Okay. All right, this one just says solve the following triangle. So when they say that, that means find all the sides and all the angles. Okay, to find this angle, all you're doing is going 90 minus 25, right? Borrow, okay? So what do you have? 65 degrees. Here's 65 degrees. So we found that side. I'm gonna just call this A, and B, and C, okay? Because that just will just help with, I gotta find little a. So let's just say I wanna find little a. So I'm going to go tangent of 25 is equal to opposite over adjacent. So little a is going to be 10 times tangent of 25 degrees. So little a is, I have to work that out. Let's see here, trig. Tangent of 25 times 10. Oops. 4.7. So this is about 4.7. So that's this value here. And again, if I want to find x, I have so many options here. One of my options could be sine. So I could say sine of 65 degrees is equal to opposite over hypotenuse, cross multiply, divide. You never put yourself at this side. You never put yourself at angle C, just so you know. Angle A, I could also do sine. Of course, I could go sine of 25 degrees equals 4.7 opposite over hypotenuse. I could do cosine of 25 degrees is equal to 10 over x. So like I have a lot of options to solve for x. Just pick one that appeals to you and solve for x like that. Tom the cat is on top of the building looking down at Sparky at an angle. Okay, so here's Tom. He's looking down at Sparky the dog at an angle of depression of 26 degrees. So this is my horizontal. Okay, he's looking down. There's that value. Fritz, the owner, is on the 13th floor. So there's Fritz. And Fritz is 13 feet up. 20 feet below Tom. So here's Tom. And what does this say? He measures the angle of depression for, there's Sparky down here. Sparky is way down here. And Tom measures, or Fritz measures the angle of depression here to be 19. So this value here, so that's 26. This value is 19. How far away is the building from Sparky? So now this is actually a little bit of a tricky problem because it does have a couple of drawings in here. And yes, I know my drawing's a little messy, but that's 19, that's 19. And basically we just want to find x. So you're just going to use tangent. You're going to go tangent of 19 is equal to 13 over x. Okay. From a point 5 meters above ground, so here's 5 meters above ground, somebody measures an angle of depression. So here's the horizontal, right? So this is going to go down like that, the angle of depression at 71 degrees. So keep in mind that value happens to be the same as this value. Approximate the distance from the object to the point on the ground. So that's going to be unknown. So again, another tangent problem. So tangent of 71 is equal to opposite over adjacent. Like I said, if you don't have a calculator, all you're doing is just manipulating this so that you can solve. So 5 over whatever tangent of 71 degrees is. Okay, so you're just, x is equal to that. And whatever that is, okay, you can work it out. But if you're not allowed a calculator, then you would just leave your answer as is. Okay, so there's a couple more applications based on the application worksheet that we did. And we can do this one right here. This says this is a challenge. It says a window washer is on a building washing windows. Let's say here this person is right here sitting out on this ledge. And it says the window washer looks at the nearby building that's 100 feet away. So here's 100 feet away, and here's a new building, okay? And so what this person is looking at, she notices that the angle of elevation is 18.7. So looking up, okay, this is 18.7 degrees. And the angle of depression to the bottom of the building, so now we have the angle of depression, which is down here, is at 6.5, okay? It says, how tall is the building? Well, this is the building. Okay, this is how tall it is. So what you're going to do with that is we're going to have to find probably this height and add them up, right? So I know these are both right angles, okay? And so this 100 goes to both. So this looks like something suspiciously like we did earlier on in this lesson. And we said that tangent of 18.7 is equal to x over 100. And then we also said tangent of 65 is equal to opposite over adjacent. So y over 100. So you're going to cross multiply. So y is equal to 100 times tangent of 65. And for this one, cross multiply, we get x is equal to 100 times tangent of 18.7. And I just have to work that out and say what x is and add it to y. Okay, so the building, let's see here. So we have 100 tangent of 18.7. And so this is going to be 33.8. So this is x, which is about 33.8 feet. And then we've got this one, which is 100 tangent of 65. And that's going to be 214.5. So this one for y is about 214.5. So all you have to do is add those two up. So add that to 33.8. And I don't know what I got, 248. Okay, so it's about 248.3. So the building is 243.3 feet tall. Okay. All right. So I hope that helps. This was applications of trigonometry. All right. Thanks for watching.